We're going to do some more traverse computations examples here. So we have another one. This one just says compute the interior angles at B and D. So this one right here and this one right here. So this is different than what we did before, because before we focused on the direction. Now we're going to work on the angles. So how do we figure this out? So again, we're going to use deflection angles to help us out. So let's redraw this real quick. So what I'm going to do is I'm going to redraw it in a way that helps me focus on the right lines. And I'm sorry, that's like the least straight line ever. So let me erase that other one. There we go. That's still pretty crooked, but bear with me. Hopefully that won't confuse you too much. So let me just use a different color. Okay. So we're going to focus on this angle right here. It comes like this, and then it goes like that, right? So that's B right here. Okay, so we know that this line is north 61 degrees, 24 minutes, 10 seconds east. Okay, great. And we know that this line is north 88 degrees, 36 minutes, 40 seconds east. Okay, those are the bearings. Now let's see if the deflection angle here helps me some. So here there's going to be an angle. We know that the angle between here and here is 90 degrees, right? So let's try to, and we are trying to find this right here. So let's see if this helps me. So the deflection at B, how can we figure this out? Well, I have right here 88. I know that this, I'm getting all tongue-tied. I know that this angle right here, this is my 88 from here to here. So if I subtract 90 from this, so if I do 90 minus that 88, 36, 40, that's equal to 1 degree 23 minutes 20 seconds. But I'm just going to leave that, that's this little one right here. I'm going to leave that there. What I want to find out is what happens when I subtract my 88 degrees, 36 minutes, 40 seconds, minus, assuming giving this, trying to find this deflection angle, this, if this is the, if this line is that much, it should be the same up here. So I'm going to subtract this minus that to give me this angle right here. So minus 61 degrees, 24 minutes and 10 seconds. So it gives me 27 degrees, 12 minutes, 30 seconds. Great. Okay, so now I know this one right here. That's what that is. So how does that help me figure out anything else? So I'm going to take 180, so the distance, because we know that this line is 180, and I'm going to subtract that 27, 12, 30 that I just found, and that's going to help me find my interior angle. Does that make sense? So I know my deflection angle, it's this one, and it's also this one. So if I want to find, what I'm looking to find is this one right here from like this big one. If I subtracted 27, actually this is what I was saying, that's incorrect. I'm finding this, right? Yeah, I totally confused you. I was like, this drawing looks incorrect. Okay, so what I meant is what we just calculated is this right here. Okay, so now if I subtract that from 180, I should get this one. So 180 0, 0, 0, 0, minus 27, 12, 30. Okay, so I'll do it this time. I know I've been skipping some calculations, but I'll be better. Okay, so I'll assume this is 60. 60 minus 30, 30. I add 1 to this one because I borrowed. And then I need to make this one 2. 60 minus 13 is 47. Okay, and then I'm going to return 1 to this one. 180 minus 28 is 152. 152, and this is the interior angle at B. Now, how do I find angle at D? So again, let me redraw stuff that's relevant to me. So let's choose another color. Oh, come on. Okay, so if I have this, then what I'm looking at is going to look something like this. Shoop. Oof, wow, that was amazing. Let's try that again. This screen is like super slippery. It's tricky. That's that line, and that's that line. So this is D, and I have, just so you know, C and E right here. And I know that here, this is, I'm being given bearings, right? So this is south 9 degrees, which, remember that south and north, I mean, it's fine if I want to see it that way. This is my deflection right here. So this right here is 9 degrees, 33 minutes, 32 seconds. Okay, we know that. What else do we know right now? Well, we know that this line right here is 71. No, I mean, this is being measured, that one, like this. So that angle right there is 71 degrees, 10 minutes, 28 seconds, which means I could calculate this right here by going 180 minus that. But okay, first things first. Let's use the deflection angle to find, so I'm going to find, I'm trying to think how to do it here most efficiently. So if I want to find this, what I just pointed at, that's easier done. Now, there's many ways to do things, right? So do whatever makes sense to you. But in this case, it makes sense to me to add that quantity to 90. So 9 degrees, 33 minutes, 32 seconds, plus 90 is equal, oh, plus, sorry, skipping ahead. Oh my goodness. Sorry, I'm making a mess here. And I'm also not giving myself enough room for it. Let's try that again. It's being a little finicky. Okay, so if I want to find, oh, I see what I'm trying to do. I am making my life difficult for some reason. I can calculate this right here by subtracting, this little angle is going to be 90 minus 71, that one. So 90 minus 71, 10, 28 gives me 18, 49, 32. Oops, these are opposites. And then, so, okay, sorry. I'm on track now. I have this, plus 90, plus this 18, 49, 32. This is going to give me 117, 82, 64. Oops, which, okay, what happens when this happens? I added stuff and I ended up with a 64. Well, you obviously can't have 64, so this is equal to 117. You add it to the next one, 8304. This is how your book has it, so that's why I copied it down this way. So anyway, okay, so we are good. What did we just figure out, by the way? So what we just figured out was this angle that we need, which is the 117 is from here to here. Okay, that's what that is. And that you're like, well, how does that help me? Well, it does, because now to find my interior angle, all I have to do is subtract that from 180. So from 180, because think about it, if I have 180, 180 is this, subtract that, I'm left with just this. So again, you may be thinking, well, I know a different way to do this. That makes more sense to me. And that's perfectly fine. I am doing it one way of many different ways in which this could be done. But you need to practice enough to feel really comfortable with this kind of material, because it's kind of like putting together a puzzle. You have certain pieces of information, you need others. There's many different ways to figure it out. Okay, so that is my angle at D. Great. Excellent. Now, I have an example here that's about magnetic declination. So what is this whole magnetic declination is when north is not really where north is. So in this example, for example, we have our normal coordinates. This is my astronomic, but this is my magnetic. My magnetic is off. So let's say that you found the survey from a while back and you figured out, actually, well, let's do this example. The magnetic bearing of the line AB was recorded as south 43 degrees 30 minutes east in 1888. If the magnetic declination, so you looked it up online and you were told that the magnetic declination was 2 degrees east. What is this astronomic bearing on the line? So what does this mean? It means that from north, you're going to push your axis 2 degrees towards the east. And this is what the people who made the survey had whenever they made. So it said survey. So if you want to find the astronomic, it's asking you for the astronomic bearing. You want to find this information. So right here I have it in the example. So all it is figuring out that this is shifted to, and that since you were being given this bearing between this line and this fake pole, all you needed to do was subtract 2 degrees. What's tricky is to know whether to add or subtract. So it's very important or very useful to draw it, because the true bearing is actually 41 degrees 30 minutes east. So you subtracted those, but you see how once you drew it, you're like, oh, okay, that makes sense. So you want to know the true bearing based on astronomic, not on magnetic. Cool. All right. We're going to stop right here.